So you have a beam which is 5 meters from the center distance, and there's a load over it. This is UDL load. Now first load is dead load. How much is that? Second load is live load. How much is that? 3. So there are 2 loads as usual over it. Now in the first step number 1, we are calculating moments and shear forces for this beam. Now what will be the movement for this beam? If this is suppose A, this is suppose B. Yes, it's simply supported. Let's take it as, it's not given in the question, we can then assume it's simply supported. If it's given, the ends are fixed, then accordingly you will change. Now, the first thing is to calculate the total load. The total load UDL acting on this is how much? 5 plus 3. 8 kilonewton per meter is the total UDL load. Then you have WU is ultimate load, and this is equal to 1.5 times 8, and this will be equal to 8 into 1.5 is 12 kilonewton per meter. What is WU? It's the ultimate load. So you are actually multiplying it by the load factor. This was the working stress load, the working load, and now you have multiplied it by 1.5. Why? Because your WU would be 1.5 of dead load plus live load, which is one of the combinations. Because now we are only taking 2 loads at this moment, dead load and live load. So the combination of the load factor is 1.5. Thereby we are getting WU equal to 12 kilonewton per meter. Now this is your WU. Now, so you are analyzing this beam AB for a WU load of 12 kilonewton per meter. Your MU, which is the movement, will be WU L square by 8 for a simply supported condition. So this will be 12. L is 5 center to center. Again, it was not given in the question whether it's center to center. The span, now you are assuming here that it was given as center to center. You have to read the question carefully whether it's given as clear span or effective span. Now, if nothing is mentioned, you take it as effective span between the center of the columns. Now, 12 into 5 square, how much is this coming to be? 37.5. This 37.5 kilonewton meter. Right? ये आपका. So, what will be the shear force? VU WL by 2 or WUL by 2. So that's 12 into L is 5 by 2, 12, 30 kilonewton is your shear force VU. Now Can you make the diagram for this? We have 12 kilonewtons. So, what is your bending moment diagram? Like this, 37.5 kilonewton meter at this point. 0 at this point, A point, 0 at the B point, 0, 0. So it's in hogging or sagging? Sagging. This is in sagging. Let's take sagging as positive. Then the shear force diagram is how will that be? Like this. That's okay. So how much is that maximum? 30 minus 30. Whatever the convention you take, plus or minus this side or that side, that does not matter. So now we have we know that in the first step the moment and the shear force. Now in the second step, what do? We are now going to begin the design. We now know the loads that are acting on this beam. The two major loads, flexural, which is bending moment, and other is the shear. What are we designing for initially? Is the flexion for bending moment. So, कैसे design करते हैं? What was the first step in design? Now that will be step 2 of this question. We will fix the dimensions of beam. So fixing the dimensions of the beam. What is D? How do we calculate D, or how do we? So first we will fix the width of the beam. Let that be 300 mm. I don't know as of yet whether I have to go for revision or not. I am just taking any value 300 mm of the width of the beam. So the depth of the beam will be, let's take it 1.5 times 300. So let this be 450 mm. There is another method to also know the depth of the beam, D required, and this is from the equation that I showed you after this last time. I'll tell you why this is okay from. Did we see an equation last time where mu was the ultimate limiting load moment? What was it equal to? There was an equation given in the code at the end. Can you recall that equation? What was it equal to? 0.316 at the end. It was 0.36. That's 0.36 into XU max by D. Into 1 minus 0.42 XU max by D BD square FCK. ये कोड में दी हुई है ये इक्वेशन. Now, if you recall this equation, अगर आप इस equation को देखोगे, what will be the XU max? How do you get XU max? By D. 0.87 FY83 इसी से मिलता है 0.362 FCK D. So this is known. Now if FO is known to us, if FCK is known to us, B and D all are known, there will still be a maximum value to this. Now that's again given in the code. The maximum value of XU max by D. Page 70. Page 70 नोट दिया हुआ है नीचे. Page 70 एक नोट दिया हुआ. Corresponding to Fy, there are values of XU max by D given. Now, if Fy is 250, XU max is 0.53. If Fy is 415, it's 0.48. 500, then 0.46. Now, in this question, what is your XU max by जो क्वेश्चन आपको दिया हुआ 500. So your XU max is by D is 0.46. 1 minus 0.42, 0.46 D square FCK. Then can you get D here now? D will be, हम इसको सिंपलीफाई करते हैं. ये वैल्यू कितना आता है? 1 minus this कितना आता है? पहले आप 0.42 into 0.46 कितना है? 0.79. 1 minus 0.79 कितना मतलब है? 1 ये आ रहा है?
जी सर 0.1 ही आ रहा है.
नहीं ये सारा कितना आ रहा है? 0.1 so this is 0.133 D square by FCK. So your D for MU limiting means, what is MU limiting? The maximum moment, because your last time मैंने आपको ये कहा, your MU, if it's greater than MU limiting, then you have to revise it. So your MU has to be less than or equal to MU limiting. Now what is MU? MU वही है जो हमने अभी निकाला. What was that for this? कितना निकला हमारा? 37 पर. MU is the load से जो movement generate हो रहा है. MU limiting है कितना ये resist कर सकता है for a balance section.
133 आपने लिखा ना यहाँ पे 0.133.
हाँ.
मल्टीप्लाई करके लिखा आपने, प्योर फैक्टर है.
ये सारा निकल रहा है लोड निकल.
तो मुझे 0.03 आ रहा है.
कितना आ रहा है?
0.03 आ रहा है.
आप फिर से चेक करो. हाँ 0.134 वही आ रहा है. आप फिर से 0.133 और 0.134. दिस इज व्हाट आई थिंक यही है. देन नाउ क्या है MU लिमिटिंग क्या है? फिर से समझो इसको. ये कंक्रीट की जब बैलेंस सेक्शन होगा, जब स्टील और कंक्रीट इकट्ठ बराबर फोर्स ले रहा है, स्टील जितना कंप्रेशन में कंक्रीट ले रहा है उतना स्टील टेंशन में ले रहा है, उस टाइम पे MU लिमिटिंग वो मूवमेंट है जो बैलेंस सेक्शन के लिए निकलेगा आपको. इसी के इक्वल आपको 0.87 Fy और जो इक्वेशन आ रही थी फॉर बैलेंस सेक्शन वो इसकी इक्वल है. सो फॉर अ बैलेंस सेक्शन जहाँ से हमें मैक्सिमम मोमेंट जो हम दे सकते हैं वो आएगा. दिस इज द मैक्सिमम मोमेंट दैट वी कैन give your section for it to be balanced. So mu limiting is equal to this value then. Now your mu cannot cross this value when it's a singly reinforced section. Remember. Now, so D will be the D required from here. You can say this is D required. Will be mu limiting by 0.133 B FCK under root. मैंने ऐसी इक्वेशन लिखी नहीं पहले यहाँ this one. So what is changing is the value of R. So this will be a general equation always for D required. What is changing is the value of R. तो R किस पे डिपेंड करेगा? यहाँ पर अगर XU max was 0.48, then you would have got something else. The value of R would have been something else. So this becomes that's a general equation for Fe 500. The value of R is 0.133. So for Fe 500, the value of R is 0.133. Thereby, why is this D required? This is minimum depth that you actually require. Why? जितना आप डेप्थ बढ़ाते जा रहे हो, what is happening with increasing depth? Your mu limiting is increasing. It's proportional because it depends more on the depth, square times. It's increasing. So if your mu this is greater than mu limiting, what will you do? You will increase the depth because you have to keep it below or equal to mu limiting for the design to be under reinforced. So what is your concept? The design has to be under reinforced. So मैंने आपको last time कहा, if you again go through that lecture, mu should be less than mu limiting. So this then becomes D required is D, or you can say D minimum. How much is that now? Mu limiting. If your mu limiting is equal to mu, which mu? जो हमने लोड इस पे दिया, अगर उसके बराबर है, I don't know what is mu limiting of the section. If it's equal to mu, then you will get D minimum. What is B? I just assumed it. How much? 300 mm. 300 mm मैंने अभी assume किया in the first step. What is FCK? Given in the question, 25 megapascal, M25 grade. So your D required now is, or minimum is, how much is mu? 37.5 kilonewton meter. I have to convert it into Newton mm क्योंकि ये mm में है. This is in Newton per mm square. This is no unit. So 10 raised for 6 kilonewton meter को मैं कर रहा हूँ Newton mm में. So 10 raised for 6 से multiply कर रहा हूँ. Divided by 0.133. This is 300 mm. This is 25 Newton per mm square. This is mm. This is Newton mm. So I converted all units into one. Now what will be the value of D minimum from this equation? 193.89 mm is your D minimum. So at least you have to maintain D minimum 193. लेकिन जब मैं अभी B का वैल्यू निकाल रहा था, what was B मैंने क्या दिया था? 300. What was D that was coming? 450. जब मैं इसको 1.5 से मल्टीप्लाई कर रहा था, 1.5 टाइम्स B मेरा. लेकिन मुझे कितना चाहिए? 193 ही चाहिए मुझे D minimum for the section to be balanced. For the section to be balanced, I require only 193. तो मैं arrange कर रहा हूँ. I'll revise my design. समझ आ रहा है? Now I have to revise my design. Why? क्योंकि मुझे minimum इतना ही चाहिए और मैं कितना provide कर रहा हूँ 450. So what will I do? क्या करूँगा? Breadth पहले मैं कम करूँगा. Let me take D equal to 200 pixel. 200 से नीचे मैं नहीं जा सकता. तब D required minimum कितना बनेगा? अब ये चेंज होगा. It's 37.5 10 raised to 6 divided by 0.133, which same 200 now into 25. कितना आएगा? कितना? You should all have calculators with you. 237.460. So 47. So 237.47 mm. तो अगर मैं अब B ले रहा हूँ 200 और इसको if I am taking B 1.5 times 200, so it's 300 mm. Now it's within the range, but this is overall D. Remember, this is effective D. This D is small d. This is effective D. So इसका ये मतलब है. Now I am reaching some point. क्या किया मैंने? अब मैंने D लिया 300 के बदले 200. उसके बाद D रिक्वायर्ड मिनिमम फिर से निकाला. कैपिटल D मेरा 1.5 टाइम्स 200 आया. कितना? 300. So now my D is 200. Your D is 300. So your effective depth will be 300 minus stirrups. We don't know yet, but at this stage I will assume, let's say for example I am using 8 mm stirrup. So cover, for example, there is no question में दिया ही नहीं है mild exposure, extreme exposure है. But for example designing for a mild exposure, you will just assume it here. It's 30 mm cover, and the bar dia, for example, I am using 16 mm, so 16 by 2. This is all assumption at this stage. डिजाइन ऐसे ही चलता है. फर्स्ट यू एज्यूम, क्योंकि आप हर कोई चीज पहले ही नहीं कर सकते हो. यू हैव टू फर्स्ट बेस इट ऑन assumption. नाउ कितना आएगा ये? 200. हाँ जी जल्दी. 254. हाँ 254 है ना? Be quick. So your D is coming to be greater than now D required or minimum. कितना है वो? 237.47 और 237.5. It's greater than this. This is the minimum that you require. Now your D that you are providing, this is providing, this is which is required or which is minimum that you require. This is what you are providing. तो आप provide कितना कर रहे हो? You always have to provide greater than what is required. But you do not provide. आप 10 गुना ज़्यादा provide करोगे जो हम पहले कर रहे थे जब हमने 300 लिया था. Then I was providing, मुझे 450 निकल रहा है यहाँ पर, so I was providing double. Now this is almost in the range. 254, 237, just 10% or 5-8% variation between the two values. वहाँ पर तो 100% variation थी in the first step when we are starting the design. But in the initial phase of the design, you don't know how to start. You take some value and then check कि हमें कितना actual में चाहिए. तो हमने एक revision इसमें करके we reach to this point. Now you will say कि मैं इसे कम कर दूँ और भी B then I take D even less than this, but 1.5 से आप कम नहीं लोगे और B आप 200 से कम नहीं लेते हो. So this is the minimum that you have to provide still, even if your D required is still lesser. So this much you have to provide. Now this was the first step in the design. Now have we now fixed the dimensions of the beam? This is now 200 mm and this is 300 mm. We have now fixed the dimensions of the beam, and then now we have to design the steel in the second step. At the same time, in the first step, while fixing the dimension, we have checked for the MU limiting, the maximum flexural forces that the concrete can take. We have checked there. But did you check for the deflection of the beam in the first step? You can check for the deflection at the same time. So step number 3 would be checking for deflections. So what was the check on the deflection? हाँ जी, अब हमने पढ़ा है इससे पहले. What was the check on the deflection? LBD should be less than or equal to 250. Is it right? What is the other check in that? What is the other check? Yes, for a simply supported beam, the value of should be 20. Page 37, sir. So the value of this is the old B was span by 250. The other check was L by D. The value of LC by D has to be for simply supported 20. Or less than or equal to 20. So LC कितना है? 5 minus. Now again here I don't know the column. I can just assume the column is 300 mm. I am assuming at this stage column is 300 mm, or any support on which the beam rests is 300 mm. Then this will be 0.3 by 2 minus 0.3 by 2. दोनों साइड से beam is resting on the column, half here, half here. So कितना बन रहा है? 0.3, 4.7 meters is LC. Thereby LC by D now will be 4.7 divided by D. कितना आ रहा था हमारा D अभी इफेक्टिव? 252. 54. So it will be 0.254 in meters.
18.5.
18.5. Now this is less than 20, जो कि कोड आपको कह रहा है फ्रॉम क्लॉज नंबर कौन सा है, which clause 20 1 2, so this clause number है for simply supported it should be less than or equal to 20. So you have maintained the check for deflection there. You have checked for deflection in step number 3. Then in step number 4 you go for steel reinforcement design. That will go for next time.